Hello and welcome to EE 233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at another example in our fundamentals demo series, focusing on the fundamentals of the C programming language. And in this case, we're going to take a look at how to cast between different data types. There's some rather unique, or I guess you could say surprising relationships that we can explore here. To begin with, this assumes that you have already been working on your fundamentals.c. As a matter of fact, we should have several functions already inserted into the fundamentals.c, but also that you have a copy of this type casts snippet. And if you don't, I'm going to take just a second to let you screenshot this. And basically what this is this is just a collection of examples that allow for us to see the relationship between integers and doubles, integers and char or characters, and then characters and integers. And there are much more, or many more examples that we could give here. But to begin with, what we want to do is we want to just go ahead and get started with this example by copying over the prototype and add that to our list of prototypes, and then also go ahead and copy the function itself as well as the comments and just simply add it to the bottom of our list. Now, as same as in earlier examples, we haven't actually accomplished anything, but you do want to go ahead and build this. We're not running the code yet, and that means that we need to go back up to our main, and we simply want to comment out any of our other examples and focus then simply on the one that we've just added, which is our typecasts demo. So typecasts accepts no input arguments, returns no output values, and it simply is a demo that is self-contained. So we make a call to the typecasts demo. All right, so let's go ahead and build it one more time. We'll come out here to the command window. We'll CLS or clear the screen of our previous examples. And then what we want to do is we want to then click on the function signature, or the prototype rather, or in this case where we called the function, and go ahead and go to the declaration. And at this point, we can go ahead and close our snippets and simply split the screen between NetBeans and our console. And now we can run our fundamentals demo.exe. And we want to talk through each one of these examples here so we can sort of understand how casting works. Once again, this is just meant to be a beginner example. This is definitely not the last time that we're going to see casting. As a matter of fact, we're going to run into it several times throughout these video series. To begin with, what I want you to do is I want you to take a look at the declaration of some of these variables. And so if you notice up here at the top, we are simply declaring a couple of integers, int underscore a and int underscore b. Likewise, a couple of doubles, double underscore a, double underscore b, and then a character. And we're going to call that one char underscore a. Now, none of these are the greatest variable names, so just keep that in mind. These are basically meant to help us keep track of the data type as well as the variable name. And you also want to remember that none of these variables have been initialized in this first block. So essentially, even though we have essentially declared our intention to have a variable and allocated the memory, the value of those variables or the value at that location in memory is essentially garbage. It's unpredictable. It's nothing that we can count on. So they've not yet been initialized. And so what we want to do now is initialize these to some set of values. And in this case, I'm just simply assigning 5 and 6 to A and B respectively. And then notice the 5.0 and the 6.0 for the double equivalent. And then for the character, now since this is a single character, we want to use single quotes. So it's important to notice that single quotes mean a single character. Now, as in earlier examples, you see that we have a nice table again. This is meant as a starting point, so I highly encourage you to play around with different examples here and see see if you can sort of discover, if you would, pattern of how this works. Now, to begin with, over here on the right side, you see that I have essentially started with the value of 5, and I then converted or cast 5 using a double. And so you see in the format spec, we have a %d indicating that the first value is going to be an integer, and then a %f, meaning that the second value we expect is going to be a double. Well, the first one's pretty straightforward. The 5 just simply is printed in using the %d placeholder, but the second one is a little unusual in that we have to prefix it, if you would, with the double data type, and we use parentheses in the casting just to indicate that we're casting here. And so we're casting 5 from an integer into a double. And so what happens now is the 5, then the first one is printed as an integer, and the second one is printed as a double. Well, let's see how this works with variables. And if you notice, there's not much of a change. Instead of hard coding the 5, we simply use the variable name. Now, it's important to notice here, though, that in this second set of parentheses, or the second value where we are casting int a from an integer to a double, we don't actually do anything at all to int a. In other words, the value of int a is still 5, and the data type of int a is still an integer. Instead, what we want to do is we can look at how we can actually take one of the values, or one of the variables rather, and cast the value and then store it in a second variable. We'll do that in just a second. For this third example here, I'm basically adding a integer to another integer, and the result then I want to cast to a double. And so what I've done here is I've specified the first %d gets the int a, second %d gets the int b, and then with an abundance of parentheses, I am simply casting using the double data type the result of the integer addition of int a to int b. Now, if we continue, we can do something similar with our doubles to integers. So essentially, we're just reversing the process. And this is probably where we're going to see a few more things that surprise us. To begin with, we first have a %f that we are going to use to print the double a. And by the way, you should just be following along up here in the console. So I'm using that %f to print the value in double a, and then the %d is used to print the value of double a after it's been cast into an integer. And so with a number like 5, it's not going to be that interesting. So we'll play around with that as well. We'll see exactly what happens when we cast a value. And so if you'll notice here, do the same thing as we did earlier, except this time I'm going to take 2 doubles, I'm going to add them together, and then I'm going to cast the result into an integer. And if you notice here, I'm essentially, because I'm using the %f and %f, I'm displaying them as doubles, and then the result I am displaying as an integer. So before we get into the characters, we want to take a look at a couple of examples, beginning with the assignment of a value after the cast. And so if you notice here, what I've done is I am taking the double a, which, if you recall, had the value of 5 in it, and I'm taking the double b, I'm adding them together, and a double plus a double should be a double, and then I'm turning around and casting them to an int, and then I'm storing the result in int a. And so what I'd like to do, just to prove that there's no magic happening, I'm going to have another print statement. In this case, I'm going to print f. How about if we have something a little more informative? We're going to say int a's, or maybe we'll just leave it as int a, and then d because it is going to be an integer, and I want to print out the value of int a. Now we'll stop here. I'm going to go ahead and build this. Once again, no errors, but I'm going to rerun it. And you'll see now that int a has a value of 11. Well, once again, not terribly interesting because right now we've been very careful and the doubles that we've picked have no values after the decimal point. So what we'd like to do is see what happens when we actually cast a value and we actually lose data or lose accuracy or at the very least precision of the value. So what we'll do now is we'll have int b, and we can choose any value here, but why don't we go ahead and take a second to go ahead and use our double A and double B. And in this case, what I'm going to do is I'm just going to do a simple division between our double B and double A. So in other words, I'm going to divide 6 by 5. And if you quickly can do the math in your head, you'll know that that should result in 1.2. So in this case, what I want to do is I want to cast it to an integer, the division of double B divided by double A. Nothing too complicated. And then what I want to do is I want to do a printf of int b. And once again, since int b is an integer, it's going to be %d. And I want to follow that up then with the variable int b. So at this point now, these no longer have their original values in there, but instead should have the new values. So go ahead and build it, go ahead and run it, and you'll see that the value of int underscore b is 1. So essentially I've lost everything after the decimal. What I want to do now is I want to investigate this just a little further. So I'm going to say printf, and in this case, what I'm going to do is this is going to be an unnecessary line, but I want to have it here just so that we can see how this works. I'm going to say int b, and I'm going to go ahead and cast using int, maybe some other division. So in this case, what we're going to do is, how about if we do something like, 1 second here. How about if we do something like 5 divided by 3. And specifically, since this is going to be a double, we're going to have 5.0 divided by 3.0. And you should notice that, or should recognize that then as 1.666 repeating. So what's going to happen here when I take this result and I then cast it to an integer? Well, let's see here. We're going to once again have int b %d because we're going to be printing an integer. And then lastly, int b, the variable. All right, and then let's go ahead and build it real quick. And then let's see what happens here. Well, once again, it's 1. And so if you notice here that essentially what I'm doing now is I am truncating. Specifically, we're actually doing the truncation here. All right, so it's very important that it's a truncation, to notice that this is a truncation. And to even be more explicit with this, if I were to do something like this, so I'm going to do an example here of 1.999, and I want to see how it gets printed as an integer. In this case, there's 1.999. I want to cast it now as an integer, and if I save it and build it, you'll see that if we cast 1.99 to an integer, we essentially just truncate the value. Once again, I encourage you to continue to play with this demo. That's the purpose of these demos, is to come up with different examples, addition, subtraction, multiplication, and division, and see how casting affects them. Now, the last example I want to give you is actually going to be to discover the relationship between characters and integers. However, before we look at that, I want to take just a second to go to another link that I'll provide you, and we're going to cover this again later, but this has to do with the Ascii Table, or the American Standard Code for Information Exchange. And essentially what this is this a mapping between numeric values and the glyphs associated with our alphabet, as well as other keyboard characters. And so what you see here is a table starting with the decimal value of 0, continuing on all the way through to the decimal value of 126, that essentially provides a mapping between the decimal values and the equivalent glyphs. Okay, glyphs are sort of a generic term for characters that also include symbols. Now, the first table is going to have what we're going to refer to as unprintable characters, and you've actually already discovered one, and that is our new line. And we'll come back to that in just a second. But if you take a look down here on the second table, this shows the relationship between the keys on your keyboard and their numeric equivalents. So for instance, an exclamation point is 33, double quotes is 34, a space is 32. But if you come down here, you'll also see the letters of the alphabet in both capital letters and lowercase letters. Now, the first thing that should pop into your mind is perhaps now that you understand a little bit better about why C is case sensitive. Well, we're going to come back to the Ascii table in just a little bit in later videos, but for right now, just recognize that there is a mapping between an integer and its equivalent glyph or character. Now, if you come back over here to our fundamentals.c, suddenly this should make a lot more sense. And specifically, if you notice, I am using Printf with a different format spec or format spec identifier, in this case a %C, which indicates a character. And earlier I had identified char_a as a single character, and that is the capital letter G. Well, what I'd like to do now is, in addition to printing out that single character capital letter G, I also want to cast it to its equivalent integer. And now if you take a look over here, capital letter G should map to the decimal value of 71. At least that's what we're hoping will happen. Now, likewise, in this second example here, I'm going to do the opposite. I'm going to start off with an integer, in this case 97. And once again, using this Ascii table, now I'm going to scroll down and you'll see that a 97 should be a lowercase a. Well, let's see how we did. If you come over here to the right, you should see that the capital letter G, when it's cast to the equivalent integer, does in fact print out 71. Likewise, the integer 97, when it's cast to a character, does in fact print out the lowercase a. And just like before, you can also use the char data type to cast between an integer value and then turn around and store it inside a variable. Now, we'll be using these casts periodically throughout the semester, but it's most important that you recognize that you can, in fact, cast between certain data types, and we will be doing that. But also you want to take a second to notice that when you cast between different data types, there is the potential for loss of information. And it's a very, very important concept that will follow you not only in C, but in other languages as well. So once again, we'll build this just to make sure that we've got this working. We'll run it one more time because we'd like to leave you with a working demo. And then more importantly, if you have any questions or comments, don't hesitate to email me. And as always, thank you for watching.